Hello students, welcome to our class and start our learning with Let's Learn. And our today's topic is Laws of Conservation of Momentum from chapter 1, Laws of Motion. So let's start. Assume that these are two objects having the mass m1 and m2. The initial velocity of first object is u1 and the initial velocity of second object is u2. We have to prove the laws of conservation of momentum. We know what is a momentum? Yes, momentum is a product of mass and velocity. Momentum that is denoted by P, and P equals to mass m into V. V is for velocity. So assume that, and we have to prove the law of conservation of momentum. That means if here two objects, let's consider A and B, both mass of both objects are m1 and m2. First initial velocity is u1 and u2. When two objects collides with each other, that means if the object A, when both objects collide like this, when the both objects collide, then object A exerted the force on object B and also object B exerted the force on object A. So after collision, the velocity of the both objects will change. Let's consider the velocity of first object is v1 and velocity of second objects will be v2. Understand? So we have to prove the momentum of the first case. That means initial momentum is equals to the final momentum. Final momentum is after collision the both momentum, the momentum of the sum of the both momentum is same. Understand? So let's start. Again I repeat it. Suppose two objects here having the mass m1 and m2, initial velocity u1 and u2. Assume both objects collide with each other. You can see here two cars here, 1 and 2. When they collide with each other, obviously their final velocity will change, maybe increase or decrease. Okay, so to prove this law, we have to write the assumption first. Let's consider, suppose that here two objects A and B. For object A, mass is m1 and initial velocity. The initial velocity we have to denote as the symbol u. So for object A, the initial velocity is u1. Let's consider. Understand? And for object B, the mass is m2 and initial velocity is u2. Okay? And according to the formula of momentum, we know what is the formula of momentum? Momentum is mv. That means m is the mass and v is the velocity. But initial momentum, just tell initial momentum. So initial momentum of object A will be m1 u1. Why? Because m1 is the mass of A and u1 is the velocity of object A. Okay. So initial momentum of B equals to m2 u2. Where m2 is the mass of object B and u2 is the initial velocity of object B. That's why I write here the initial momentum of both objects. It's clear? Then when they suppose these objects collide, suppose that let's consider. So assume that let the force on A due to the object B equals to 5. Just assumed. Understand, student? Let the force on object A due to B, because the two objects A and B collides. So the force on A due to object B is F1. And then cause of this force, the object accelerate, because two objects collide. And so because of the force exerted to each other, consider the object A accelerate and its final velocity becomes v1. So the momentum of A, that means the final momentum changed. Momentum is mv. So m1 is the mass of the object because mass is not changed. So m1 v1, because after collision the velocity of object A is v1. I considered here. Okay, so momentum will also change, m1 v1. I hope understood, student. Okay, so and according to Newton's third law, we just studied the Newton's third law of motion. What is this law? When the object A when the two objects collide, when one object exerted the force on the other object, second object, then second object or other object will also exerted the force to the first object. This is a Newton's third law of motion. So because according to the Newton's third law, when object A also exert an equal force on B, okay, and this cause the final velocity of object B will also change. And let's consider the final velocity of object B is v2. So that's why the momentum of B after collision is m2 v2, because v2 is the final velocity, m2 is the mass. So m2 v2. Understand? So here final momentum after collision, the momentum of A is m1 v1. After collision, momentum of B is m2 v2. It's clear? And let's assume the F2 is the force that acts on the object B. We considered here F1 is the force that acts on A because of B or due to B, and F2 is a force acts on object B because of object A. Understand, student? F1 is a force acts on A, F2 is a force acts on B. So then F2 is equals to minus F1. Why minus F1? Because the direction of both force is opposite. The F1 and F2. This is F1 and F2. You can see here the direction of the both forces are opposite. So right here F1 equals to minus F2. Then let's put the values of, we have F2 equals to minus F1 or F1 equals to minus F2. You can write anyone, F2 equals to minus F1 or F1 equals to minus F2. Now we know one formula, F equals to ma. So put this formula here, F equals to ma. So F2 is the force acts on B. So right here F equals to ma. We know this formula. So m2 a2. Instead of ma, put here m2 a2, because m2 is the mass of B, a2 is the acceleration of B. And then F1, in place of F1, put here minus m1 a1, because we know this formula, F equals to ma. So for object A, put here m1 a1. Then again we know one formula, A is acceleration, is a change in velocity upon time. So put here m2. Instead of a2, put here v2 minus u2. v2 minus u2, because a2 is the acceleration of object B. So final velocity of object B, initial velocity of object B upon t equals to minus m1, then a1 means v1 minus u1 upon t. Understand? Then cancel out here, t and t cancel. So m2 into v2 minus u2 equals to minus m1 into v1 minus u1. Then open the brackets, m2 v2, m2 into v2 minus m2 into u2 equals to minus m1 into v1, then minus minus plus, here minus minus plus. So m1 into u1. So write here m1 u1. Then m2 v2. Then change the final momentum here. M1 v1. Change the side of m1 v1 and put here plus sign. So m2 v2 plus m1 v1. When we change the side of the any variable or numbers, then we will change the signs of their signs. And m1 u1 plus m2 u2, because here m2 u2 is in minus symbol. So change after changing the side, m2 u2 plus m2 u2 here. That means you can see what is a m2 u2, what is a m2 v2. m2 v2 is a final momentum of object B. m1 v1 is a final momentum of object A, because V is the final velocity. Here V is the final velocity. So m2 v2 is the final momentum of object B. m1 v1 is the final momentum of object A. Understand? So in the left hand side we got the final momentum of object B plus final momentum of object A. And in the right hand side, m1 u1. m1 u1 means initial momentum, because u is the initial velocity. So that's why m1 u1 is the initial momentum of object A, because here 1. m1 is the mass of object A. So m1 u1 is the final momentum of object A plus m2 u2 is the initial momentum of object B. Initial momentum of object A plus initial momentum of object B. So it's clear, you can see the final momentum of object, sum of the final momentum of the two objects will equals to the sum of the initial momentum of the object. That means the magnitude of the final momentum is equals to the magnitude of the initial momentum. Understand? So what we conclude? So conclusion is, if no external force acts on it, if here two cars, if here two objects, and we apply any external force from any direction, other direction, okay, so this law will change. But here condition, if no any external force is acting on two objects, then at that time the total initial momentum is equals to the total final momentum. Total means the momentum of A plus momentum of B. Momentum of first object plus momentum of second object. Understand? So conclusion is, if no external force is acting on two objects, then the total initial momentum is equals to the final momentum. If the question is asked, write down the law of the conservation of momentum for 1 marks, then you have to write the, if no external force is acting on the two objects, then the total initial momentum will be equals to the total final momentum. Understand? If the question is derive the law of the conservation of momentum, that is the final momentum is equals to the initial momentum, then you have to write all the from this law of conservation of momentum. First write your assumptions for both the objects and then put the formulas here. Put the formulas. F2 equals to minus F1. Then put all the values. Value of F2, value of F1. Value of F2 is F equals to MA. So M2 A2. Here M1 M1. Understand? Put the value of the acceleration, V minus U upon T. We know this formula. Then T and T cancel. Then multiply M2 in the bracket and conclude your this statement. The magnitude of the final momentum is equals to the magnitude of initial momentum. Understand? I hope you understood. Student, if you have any doubt, then you can comment on this Google Classroom. and use this code to get homework, notes and solutions. Thank you very much.